Welcome to By Excellence Tutorials, and today we are going to look at a kinematics question. Kinematics. So if you have not yet registered, subscribed to the YouTube channel, kindly do so and make sure you hit the notification bell so that you get notified each and every time I upload a new video. So we have a question here that is from kinematics, as I stated earlier, and it says two marbles are launched at time equal to 0 in the experiment illustrated in the figure below. Marble 1 is launched horizontally with a speed of 4.2 meters per second from a height of 0.95 meters. Marble 2 is launched from the ground level with a speed of 5.94 meters per second at an angle of 45 degrees above the horizontal. Where would the marble collide in the absence of gravity? So I want you to mark that one, in the absence of gravity. Okay, so we're going to start with the same question A. So you need to understand one thing here, that for marble 1, in the absence of gravity, meaning there is no gravitational acceleration to pull it down or to bring it down, it is going to continue moving in the horizontal path. Because we know that what brings objects down, particles down, when they are thrown or they are released in the air, in the space, is gravitational acceleration. But in this case, in A, we are told to say we need to assume gravitational acceleration is not there. So it means the marble 1 is going to continue to move in the horizontal path. Okay, and then for marble 2, it's going to move from this point, the initial point, it's going to move up to the height at which marble 1 is going to be moving, which that height we've been given is 0.95. So that height is actually our vertical component. We are asked to give the components, X and Y components. So that height will be the same vertical component throughout. Okay, so what we need to calculate here is the X component. So now, how do we calculate the X component? It's by first calculating the time it will take the second marble to reach the height of 0.95. And that is how we are going to be able to get to the X component, or rather the range, in other words. So marble 2 is launched at an angle, okay, at an angle 45 degrees. So we have to resolve that velocity, initial velocity, of course, and the vertical component is going to be 5.94 sine 45. So that would be the vertical component. So like we are saying, the marble, the first marble will continue moving in the horizontal, and this will have to meet it, maybe somewhere there. But mind you, this height will still be the same as h, which is 0.95 meters. So that will be our y coordinate. We already have the y coordinate. What we need is the x coordinate, this coordinate. So in other words, the range. Okay, so we write the equation of motion for the second marble, of which we know that height, final height minus initial height, okay, should equal to initial velocity times time plus half gravitational times time squared. So now gravitation is absent, so this is 0, it's cancelled, it's not there. And our initial height is also 0. So our equation is going to reduce to height is equal to 5.94 sine 45 times time. And our height is 0.95. Sine 45 times time. So we divide throughout by 5.94 sine 45. Even the other side, we do the same, 45, so that we get our time. And our time is going to be our time is going to be 0.226 seconds. So that will be the time it's going to take this marble to reach that height. So now we can be able now to calculate our range, or the x component, of which we know that our range is given by that equation, and the initial position is 0, so we get 0 there, and then we have 5.94 as our initial speed in the horizontal, and then we multiply it by our time that we have found, which is 0.6. So what we are going to have here is okay, so we are going to have 0.949 meters as our x coordinate. So the coordinate system at which these two marbles are going to collide is going to be 0.949, 0.950, and this is in meters. So this is how we get to calculate the coordinates where these two marbles they collide. So we are going to solve B in the next video. Make sure you subscribe to the YouTube channel and hit the notification bell so that you get notified each and every time I upload a new video. Thank you for watching. See you in the next video.